Alright, it's starting.
Hey, Brian. Shut up.
So why do good girls like bad guys? I had this question for a real.
In order to align the laser bore, we adjusted the position, the tip and tilt of both the bore and the mirror until we saw the clean laser beam coming through. And we know it's well aligned because we are actually seeing a fringe pattern coming through.
So the anode and cathode were already connected, so all we did was we flipped the switch, and then we adjusted the tip and tilt of the mirror as well as putting in the loss mechanism so that we could see different order modes on the observation screen.
We used the spectrum analyzer to measure the delta nu of the Heaney laser, which is this value right here, separated by these two dots. Here's the output from the Fabry Pro interferometer. We measured the separation between the peaks using the cursors, moving it like this. And we just make sure we measured between these two peaks and then also these two peaks, and we got about 500 microseconds as shown there.
For the Fabry Pro experiment, we measured a cavity length of LM equals 38.3 centimeters, just using a standard ruler, which gave us a frequency of 392 megahertz. And then the frequency from the electronic spectrum analyzer was 436 megahertz. And then we measured delta T from the Fabry Pro of 500 microseconds. Using that, we got a frequency of 410 megahertz. And from there, we calculated a length of 36.6 centimeters, which makes sense because we were told that the given cavity length inside the laser will actually be shorter than the actual length of the laser, which is what we used for our initial measurement. So how a Fabry Pro can be used to analyze a spectrum is that these being emitted from the Fabry Pro create an interference pattern which creates fringes, and those can then be used to analyze the spectrum. So for the beam width experiment, we varied the distance by 2 centimeters when we were up close to the laser, by 5 centimeters when we were in the middle range from the laser, and by 10 centimeters when we were far away from the laser, since when we get far away it should act linearly. And we took the beam width value by taking the mean value from the screen and dividing it by 2.
Here's our graph for the beam width experiment. We have all of our data points plotted here. We have both a parabolic fit and a linear fit for the last 3 points, which allows us to calculate the beam waist, which is right here at -7 centimeters. The beam waist is calculated to be 228.9 micron. The calculated divergence for the laser beam was 8 times 10 to the minus 5 degrees, or 288 milliarc seconds, and our numerical aperture was 4 times 10 to the minus 5.